Let's kick it off. Again, warm welcome officially to this Azure Data Explorer Level 300 workshop. This is something that we planned for a long time. So thank you very much for attending this really nice live event. Thank you as well for Diana for setting everything up. Today we're going to start with our first day. The agenda is going to be what you see on the screen here. So immediately we're going to start with an overview about Azure Synapse Data Explorer by Odette. I'm very happy that he's joining us. Right after that, Svia is going to take it away by talking about an overview of ingestion methods in ADX. And then Slavik is going to finish today's session by talking about KQL overview, so Kusto Query Language overview and optimizations. Next slide, please. On the second day of the agenda, we are going to do an entire 2.5 hours of a hands-on lab. And the idea of this hands-on lab is that your developers, you are enabled to build your own environment, maybe a demo environment, including a good amount of really nice Azure Data Explorer or Kusto features. So we're going to ingest data, we're going to create a schema, we're going to use update policies, materialized views, partition policies, and many other things. So the intention of this session is that you can watch it later and probably try to do the same thing as we did in this 2.5 hours. It also comes with scripts and everything that you need. So this is going to be a really nice one. Next slide, please. And last but not least, on the third day, we're going to come to the more advanced topics. So the more advanced topics are around time series, machine learning, and process mining in ADX. My friend Vincent Philippe is going to talk about that. After that, it's either me or Avner who is going to talk about features for optimizing for high concurrency applications using Azure Data Explorer, such as web applications or mobile applications talking directly to Azure Data Explorer. And last but not least, a very important topic is about visualization using Power BI, Grafana, and our ADX dashboards presented by Dani and Gabi. And again, I see we're getting more and more attendees. Welcome to the session. You didn't miss anything. Just a brief agenda introduction. And now I'm going to hand over to Odette to talk about Azure Data Explorer. Odette, please take it away.
Hey, thank you, Henning. I hope everyone can hear me well. My name is Odette Satcher, and I'm the General Manager of the Azure Data Explorer product team. Thanks for joining us today and for the rest of the week to learn about homegrown disruptive technology that completely transformed Microsoft's own digital transformation journey. A journey that starts with a huge amount of telemetry data. Telemetry data is everywhere. We find it in IoT sensors, in application logs, click streams, user activity, security. It drives advances in the connected devices we find at our homes, smart buildings, smart factories, and the services that consumers and businesses rely upon. It is actually the fastest growing data segment as we race to instrument everything, and expected to reach staggering numbers of volumes and connected devices in the coming years. Every traced activity by humans or machines can be used to optimize our products, our user experience, and how we operate our businesses in general. Telemetry data, the digital imprint of every activity, is fueling digital transformation, and it's generating petabytes of data every day. It fits into the classic 3 V's of big data, being the variety, velocity, and volume. Very often, it includes a lot of text and semi-structured data in addition to structured data. It is streaming in extreme rates and low latency, and obviously it accumulates to huge volumes of data. The data is typically timestamped, and its schema is constantly changing to be able to meet the ongoing changes in the real world where those records are generated. So what makes observational analytics or telemetry analytics so special? What is the challenge in driving meaningful insights from this type of data? So first, the velocity of the business environment is accelerating. We have the information flowing in, and we are expected to use it constantly to improve how we operate. The model and the report we created last week might not help us identifying the next week opportunity, and the need for ad hoc insights is constantly growing. Second, the data keeps changing, with new types of versions of devices or applications, changing vendors and business partners, and the evolution of information needs that drives deeper data collection. A lot of that is encoded in text or semi-structured JSON data. And ETLs, like old-fashioned ETL, cannot really keep up with the constant change to put structure into the data. So we need to take decisions out of this semi-structured data. And last, the decision need to be made in near real time based on fresh data. Such vast amounts of data requires extreme efficiency to be able to perform it without emptying the pockets. Typically, the major cost-driving factors for these workloads are the hot storage and the compute needed to process the data and answer queries. Tabula is one of the world's leading discovery platforms that helps more than 1.4 billion monthly users to explore what's interesting and new across the open web, generating approximately 30 billion of personalized content recommendations every day. With their previous on-premise solution, they used to sample to 10% of the data to be able to continue monitoring SLA. Doing that, losing the ability to troubleshoot and conduct root cause analysis over the entire raw data. Another unique challenge in observational analytics is the need to get answers and insights for unplanned phenomena. You need to get insights from the data, not knowing in advance how best to organize it and prepare it to answer the next question. Think of security attacks, malfunctions in live service, users and commerce trends, frauds, or manufacturing failures. All of those and more usually require ad hoc analysis of raw data to be able to get meaningful insights. Checkpoint is a leading provider of cybersecurity solutions to governments and corporate enterprises globally. They are collecting network and security telemetry to help protect their consumers from fifth-generation cyber attacks and offering SaaS services for analytics. CBS Interactive, Tabula, Checkpoint, Microsoft, and many other companies understand the business opportunity that lies in telemetry data and the associated challenges that comes with it. All of them picked Azure Data Explorer to realize that potential. So what makes ADX, Azure Data Explorer, a perfect fit for observational analytics? At the heart of it, there is a super powerful relational analytics engine that supports filters, aggregations, joins, driving calculated columns, and many more powerful operators. It has native support for telemetry data from structured to semi-structured all the way to free text. And the data itself is available for query within seconds to support near real-time insights. Leveraging a unique combination of column store and inverted index technologies, ADX offers. So now I want to take you back a little bit, like 9 years backwards in history and tell you about the journey we've done with Azure Data Explorer in Microsoft. So 9 years ago, together with three friends, we founded Kusto Incubation Project, aiming to disrupt the way engineers at Microsoft are exploring telemetry data and derive meaningful insights for the business. We named the service Kusto after Jacques-Yves Cousteau, the deep sea explorer, as a solution for exploring the ocean of data. The service spread like wildfire in Microsoft and changed the way digital transformation is practiced every day across the company. Every machine running Windows or Office, every Xbox device, all Azure services, from the core infrastructure to Dynamics and Power Platform, are sending their telemetry to Azure Data Explorer to understand how they are running, the user experience, the faults, and the opportunities. ADX is also the underlying warm store for Azure Monitor, Application Insights, Azure Security Center, Sentinel, IoT Central, PlayFab, and more. All these services offer a fit-to-purpose end-to-end solution which is based on the customer's telemetry data stored in the underlying Azure Data Explorer. For years, Kusto was one of the best kept secrets in Microsoft, an internal-only service that's used by every product group across the company. Only 3 years ago, it was made available to the public as Azure Data Explorer, and recently joined Synapse product family as Synapse Data Explorer. So Kusto, Azure Data Explorer, Synapse Data Explorer are synonyms for the same technology and service. Since we launched Azure Data Explorer to the public, we've seen similar usage patterns to how it is used in Microsoft across various industries and verticals. We experienced strong adoption with security vendors, oil and gas companies, in the automotive industry, and with media providers. The two main patterns are again very similar to Microsoft usage of ADX. As an enterprise telemetry solution, which consolidates and correlates the enterprise logs and events data across on-premise and clouds, or as a data platform used to build analytics features and products that handle telemetry data. To give you a sense of how much the service is used, take a look at these numbers. ADX is ingesting 115 petabytes of new data every day, which accumulates to over 8.1 exabytes of data. The service is deployed in all Azure clouds, regions, and data centers with over 2.4 million cores answering 2.5 billion queries every day. Queries which are written by over 350,000 KQL developers. What's even more remarkable is that those numbers are growing close to 100% year over year. And that's a good point in time for another demo, this time a live demo on how I'm using Kusto or Azure Data Explorer to explore the ocean of data. In this demo, it's the telemetry data coming from Power BI, the service. As I said, Power BI is one of the services like all other Microsoft services which sends their telemetry to ADX. So I'll switch screens here. That might take a minute or a second. So hopefully you can see the screen, right? So here I'm connected to the web experience of Azure Data Explorer. I'm connected to a cluster. You can see the cluster here is called Demo 12, and to a database called SQL BI, which was the previous name for Power BI. And in this database, I have telemetry data coming from the service from Power BI service. You can see here I have few tables, total of 32 petabytes of data, which are stored, which are indexed and compressed and stored in the local SSD. The compressed data size is 3 petabytes of data, so roughly 10%. 10x compression factor. The cluster itself is running on 6 nodes in Azure, so not a very big cluster. And let's start to see how the data looks like. I'll start with the trace table. You can see I've here how the traces or the records look like. It's a typical trace table with timestamp, some dimensional columns where there was the tenant, the role of the node, the level of the trace. And if I scroll all the way to the right, I will see there's the event text column has actually like free text. That's the traces that the developers wrote when writing the code. So as I said, Kusto is a perfect fit for this kind of data. And what I can start doing is just to get a sense of like how much data I have and how it's distributed by the trace level. So I'm taking the entire 41 billion records here. I'm filtering for a specific day and then running aggregation on the column called level. You can see that it filtered out 800 million records and run aggregation on that to 5 different buckets, all of that in like less than a second. which is quite impressive for every analytics engine, and in that scale, it's actually super impressive. But that's only like the start of the exploration. Let's take a look and again, back to the data. I want to understand if you're like how the sample trace line looks like for errors. So I filtered for a level equals 2. So I can see that the error spread by role instance, but I do want to understand how the errors are spread based on the role itself and not the role instance. So, but I don't have that column right here that I can use as part of my data. So what I'm doing is I'm using Kusto to basically create a new calculated column in runtime. I'm calling it role type, and I'm parsing the information in the role column, extracting only the first part of the data until the underscore, and skipping all the rest. And when I'm running this query, I'm actually creating a new, I'll skip the chart, for example, I'll go to the data. You can see that I've created a new column called role type. It has only the type of the role, emitting the instance, and then aggregation on how many errors that specific role type add in each 10 minutes bucket. And then back to the chart, I can see very clearly that there are like that role here at the spike, while that role, the SharePoint integration role, actually had a pretty high and steady rate of errors along the way. But I won't get into that investigation too much. What I'm trying to do now is actually to look for the most frustrated user of Power BI in a very specific data that I'm looking at. To do that, I will go back to the data and run self-join on the table with two data sets which I'm creating from the raw telemetry data. The first one is I'm extracting all the trace records where the event text had that traces were actually coming from the gateway that authenticated the user, which means that the user was successfully authenticated or a session is created. And then I'm extracting the user ID and the session, the client activity ID, and then correlating that back with all the errors. Okay, so on one hand, I have like 2 million errors. The other data set has about 20,000 different sessions, and I'm joining them together to be able to count how many errors I have by user ID. And now I will run that query. Again, remember, starting from 41 billion records, creating those data sets and joining them together, I can see clearly that this user ID has like 2,000 errors in that specific day, which is sounds like a lot, which makes me interested enough to continue the investigation. So I'm going to focus on that specific user. I'm taking that user ID and looking only for his sessions and joining them back into the errors. I'm extracting from the event text, I'm extracting the top of the stack to see like what kind of error that specific user encountered, to see if there's any pattern here that I can follow. Running that query, again, give me a very clear indication that the user suffered from these two major errors. Database does not exist exception, and then some communication error or something like that. And now what I'm left to do is just pick one failure out of the 2,000 and get all the traces back. Again, remember, I'm running on the raw telemetry data, so I can run aggregation joins, but then go back to the telemetry itself to understand what's going on in my service. You can see that the session started like regularly, but then somewhere down the road, sorry. Oh. I'm having trouble searching here, but anyway, I'll try to scroll down. Oops, there it goes. Here it is. Okay, so you can see that somewhere down the line, I see that error, the database does not exist exception. And as a developer in the team, I can now go through that traces and understand if that specific error is really a bug or something else that needs to be followed up with. So starting from a 41 billion records table, not really knowing what I'm looking for, and then actually finding the needle in the haystack, okay? Identifying the specific user that suffered the most failures in a specific day, understanding what kind of errors, like bucketing the errors into the different types that user suffered from, and then going back to the raw traces to understand and troubleshoot exactly what happened in one example is a great, powerful tool for any developer that is operating live services. I will now jump to the another table there that is actually the performance counters table. Okay, so it's also you can see that how the data looks like. Again, timestamp, some dimensional column, and then the counter name and the counter value, which are similar to like a time series database in a way. It's also a pretty big table, 35 billion records here. And the query that I'm running here is trying to look for, again, that specific data that I'm querying for, it's trying to look for the 3 machines that reach the highest CPU. And then for these 3 machines, go back to, again, the entire data and chart how they behave along the day. So how their CPU behavior looked like along that day, charting that specific 3 time series out of the millions of time series that are out there in that table. So you can see that I found 3 machines that reached the highest levels of CPU in that day. This one here at the spike, these 2 had different pattern. By the way, this spike, I went back to the traces, as I have also the service traces there, and we found out that at this specific time the service was restarted, which makes sense. And the other 2 is interesting. Okay, that's a different pattern. So what I'm going to do now is try to we'll use Kusto or ADX to find whether there are other machines in that cluster, in the Power BI cluster, that exhibit similar behavior, like step behavior in the CPU. And so to do that, I'm using some time series analysis capabilities in the service to do time series shape detection. And you can see that I was able to identify additional 4 or 5 different machines that had similar behaviors. Now, if I was just trying to visualize hundreds of time series on the chart, I wouldn't be able to find anything. But using the time series shape detection functionality in ADX allowed me to very quickly find other nodes that showed similar pattern. So just go back to the slide deck. So with that demo, I'll go another step deeper and talk a little bit about the architecture of the service. It's a fully managed service, so you don't have to maintain any infrastructure at all. The cluster, a typical ADX cluster, includes 2 types of compute nodes: data management, responsible for ingestion and background job. It provides managed ingestion pipelines for Event Hub, from IoT Hub, and storage. And the engine nodes are responsible for caching the data on local SSDs and running distributed queries. The compute and storage are totally decoupled, and it can grow and shrink independently based on the load. On the left-hand side of the architecture slide, you can see the list of supported data sources And on the right-hand side, there's the different integrations and tools that you can use to access the data. ADX also supports query federation across other ADX clusters with SQL, with Cosmos DB, Azure Digital Twins, as well as various formats of data which are stored in the data lake without the need to ingest it into an ADX cluster. So very powerful and very comprehensive ecosystem, both for getting the data in, query the data in other sources, as well as visualizing that and running all sorts of development and automated flows or dashboards on top of that. Obviously, that goodness comes with a price, but we have a very flexible cost model, which makes ADX highly competitive for these workloads. This is a cost-plus business model where you pay for the underlying compute, networking, and storage transactions, and then add the IP markup, which correlates to the compute used. This model allows you to explore your data with predictable costs. It supports decoupling of storage and compute and choosing from a variety of compute SKUs to best fit the specific workload. So for example, you can take a storage optimized SKU for caching lots of data, or a CPU optimized SKU for query heavy workloads, a dev test SKU which costs less than $200 per month. And recently, we've also introduced the option to start for free with a personal ADX cluster, and we're very happy to see how it is picking up within our community. Late last year, we've announced Azure Synapse Data Explorer, extending Synapse to handle observational analytics. ADX, that used to be the main technology in Microsoft for running analytics workloads over telemetry data, is now part of the core strategy of Azure Data Analytics. ADX in Synapse is fully integrated and interoperable with the other Synapse components, providing coherent and simple enterprise-ready management experience and removing barriers for data sharing across workloads. The ADX engine is built into Synapse Analytics runtime layer, standing side by side with the existing SQL Apache Spark engines and SQL and Apache Spark engines. We've taken Synapse an additional step forward to become a unified analytics platform composed by the best-in-breed analytics engines. In Synapse, you can run your modern data warehouse workload, your ETL workload, your data science workload, and your observational analytics workload, all seamlessly integrated under a single unified product group. Our goal is to be best in breed for observational analytics in the industry, and here are just a few examples for the latest improvements that will keep us there. We invest heavily in ensuring ADX analytical power is ahead of the competition for telemetry data in performance, cost, and scale aspects. Our new engine V3 improved indexing and query execution, so we saved over $100 million that Microsoft product groups spent on ADX last year. We constantly introduce new query capabilities and support new scenarios, for example, the scan operator for sequence analytics. Data management is also a core area of investment, ensuring the data is efficiently ingested and later organized for performance exploration. We introduced materialized views, which are used to drive dashboards performance over huge amounts of data, and partitioning for high cardinality data like IoT time series data. The separation of storage and compute allows us to provide in-place data sharing, which is also commonly used not only for sharing, but also for isolating different workloads running over the same data. A very powerful feature. In the workload management space, we announced private endpoints for network parameter and predictive autoscale, which proactively scales the cluster in and out based on analyzing the historical usage of the cluster. We also know that different customers like different ways to explore and visualize their data, and we want to meet them where they are. Whether they are recently migrated from Elastic and used to work with Kibana, Power BI users that use Power Query to connect to their data sources, not writing queries, or an engineer that builds operational dashboards. All of these improvements are based on the feedback we collect from our customers and all of them make ADX a mature data platform that keeps evolving at high speed. Being part of Azure and a core service to Microsoft operations, Azure Data Explorer is fully enterprise ready with all the key capabilities you need to get from a to get into production. It is globally available, fully integrated with AAD, has role-based authorizations. It supports Azure Availability Zone and integrated with Azure Monitor. It offers network perimeter security and data privacy features like customer managed keys and purging of personal data. As I said, a battle-proven technology and service ready to power your mission-critical workloads. So before we get to some Q&A, you can see here some useful links to learn more about the product, to stay connected with the product team, with us and our community. And for those of you who are new to ADX, get your hands dirty with a simple click of a button. You can just simply click the Start for Free link and get your stuff rolling. And with that, Henning, I'll pass on the control back to you for moderating the Q&A if we have anything.
Hey, Odette, thank you very much for this. Very, very cool to see all of this content. And actually, we had a couple of questions. Let me go from top to bottom and see what are the most important ones. But of course, there were a lot of questions for the recording. So on logistics, you get the recording eventually. If not, feel free to reach out to me. Say hey Rauch at Microsoft.com. And you get the recording and whatever else you need. Then questions on technology were related to hot versus cold. So there was a question, like the demo that you showed on the Power BI data, like how much of the data was cold, how much was hot. So maybe like in general, can you share probably your thoughts on technology on this hot versus cold storage, why it's actually good to do that and where our customers are using that?
Yeah. Great question, Kusto. Like the magic that you've seen in the demo and is coming from the fact that the data is cached on SSD. Okay, so as I've shown in the so in that aspect, when we talk about like the temperature of the data, all the data is always persisted in blob storage. So whether the cluster goes up or down, we never like the data is still there. But in order to get the performance, the magic that you've seen, the interactivity over petabytes of data and 40 billion records in a few seconds, the data needs to be cached in SSD. And Kusto supports, you can define that like how much of the data you want to retain altogether. We call it retention policy, so for how long the data is kept. And then on top of that, you can define a caching policy to define how much of the data you want to be available for immediate query as a hot data, and get the performance, the predictable query performance that you've seen in the demo. For the data which is not locally cached on SSD, it will be retrieved from cold storage. In addition to that, as I said, we also support querying data which was never ingested, which means that it's not stored as in a column format. We didn't build the inverted index for text searching and all that stuff. So you can still query that, and the performance will be in part to that. So like not as fast as you've seen, but usually good enough when it comes to do that kind of queries and join with other data. But again, the sweet spot of Kusto, the magic, the fun is when the data is cached, and the retention policy and the caching policy allows you to actually control, to define the specific working point and manage the trade-off between the cost and performance needs of the specific workload.
That's great. Thank you very much for that. One more question on caching, caching of data, and then we go to APIs. Okay, so caching of data, and again, like all of the queries that I've shown, they return super fast. But tell me a little bit more about the computation of those KQL commands. Every time you execute them, are they going to be recomputed and then returned to the customer, or do we also have a feature to cache the results of the query?
Yeah, so in the demo, the queries were like computed and returned the results. Okay, so every time I hit a query, it was sent to the backend cluster, those 6 nodes running in the cloud, and the query was translated into a set of operations that were sent to the nodes, and the data was scanned, the results were calculated and sent back to the customer. We also have the option to define caching, results caches. It's roughly a new feature, so like new like in, I don't know, 1 or 2 years, but it's not something which is heavily used, but definitely for some use cases or operational dashboards, for example, that constantly send exactly the same data. That's something that some of our customers are using for caching.
Wow. Yeah. Okay. Cool. So maybe one last clarification. You mentioned a lot like hot data, which is cached on SSD, and cold data, which is always stored on the underlying storage accounts. But is there actually a difference from a user point of view when he's writing a query? Does he need to specify that he wants to talk to query cold data, or is it handled by the underlying system?
No, so the user does not need to specify anything. It just sends the query data, and if all the data is cached, then the results will return very quickly. If some of the data needs to be retrieved from cold storage, then there will be a performance hit until the data is read. And then, by the way, it will be cached for future queries. We do keep some of the caching space of the local SSDs for the data which is retrieved from cold storage for queries, so the subsequent queries will be fast as well. So the user does not have to specify. We do have like advanced options that users can, with some query options, define that they only want to query hot data and never go to cold data, but then they will get partial results. But that's, again, advanced features that some of our customers wanted.
Cool. One last question for you. We have a question in the chat that is talking about Spark. Can you please share some insight on how to interact with Spark and Kusto or ADX, or is there a way to do interoperable queries, for example, from Spark to Kusto?
Yeah, definitely. So making Spark and Kusto work together is definitely a scenario that we hear a lot from customers. And as I said, when I talked about Synapse as a unified roof for the different analytics engine that Synapse hosts, so whether it's data warehouse, ADX for telemetry analytics, and Spark, which is there for data science or ETL, definitely there's a lot of value there. The way customers are currently making Spark and Kusto work together is by using our Kusto Spark connector or ADX Spark connector, which allows you to run Spark jobs from Spark on the data which is already stored in ADX. We also have the capabilities in Kusto to export the data from Kusto to the data lake to storage in Parquet format, for example. Then you can use Spark on the data lake on data which was exported from Kusto and just do your job there. We also have a notebook experience which can be used from Spark or from notebooks to run on top of your data in Kusto. So there's like all sorts of valuable integration scenarios between Spark and Kusto, and we see that being used by many of our users.
Excellent. Thank you very much, Odette.
Thank you, Henning.
Okay, so this actually means that we are done with the first session of our workshop. Thank you very much for staying with us. And now actually I'm super happy and honored to have the great Svea with us. Svea is going to talk about data management, ingestions. And by the way, Svea, be warned. So the crowd already asked questions about latency, ingestion latencies, what to expect. And by that, please introduce yourself, take it away, and have fun.
Wonderful. Thank you, Henning. Thank you, Odette, also for a wonderful session. And thank you, Henning, for handling and arrange everything. So my name is Svea Gitlin. I am also from the product group. I am a PM manager that lead the data management, user experience, and also some of the new features that are upcoming to Kusto. And I'm trying very hard to update with status and new features and new capabilities in our LinkedIn. So if you want to hear any updates about Kusto, don't hesitate to follow my LinkedIn account. I trust you that you will ping me whenever there are questions. I don't see them.
Yep.
Okay, so let's start. So, so what we are going to talk about in the next, let's say, 30 minutes is about data management. In Kusto, there are main three components: the engine, the data management, and the control management. The DM is responsible, first of all, to pull data from external sources and add links into Azure queues, convert, format all the formats. There are a very long list of formats that are supported by Kusto. The DM, the data management, responsible to convert them in one of the supported languages by the engine. Also manage the load to verify all the time that we have the right load on the CPU. And if needed, also throttling and retries to verify that we have ingestion success rate end-to-end of the ingestion processes. The data management is responsible to manage the data as part of the, to arrange the data, to manage the data, to merge the data, or to divide them into different slots in order to bring the most efficient data structure later to the engine to ingest that will impact significantly on the query performance. ADX support different data types, the tabulars with CSV, TSV, PSV, also different types of JSON, line separated, multi-lines, different, whenever they're needed, we add it. There is the Avro, there is Parquet, and we are working all the time to add new feature, new formats. Now we are working to add Delta Parquet. It will take some time, but this is a work in progress as well. And we can, the data can ingest into the service compressed or not. And Azure Data Explorer just get it. The idea behind that, we would like to bring the data and to simplify the ramp up into Kusto, and whatever your data exists and however it exists, just to have a slight forking of the data into Kusto and start to work on that. As part of the flow, whenever you start to ingest the data, as part of the ingestion command and the ingester pipeline, and whatever you do it, there is also an option to add mapping. In some of the formats, it's mandatory, but in most of the formats today, it's optional. But mapping, actually, it's a very powerful tool. The mapping is an enabler of ingestion from multiple different structure, variety of structure, format, sources into one table without the need to have different logic or to have different code to support it. The mapping is it's a setting, it's a definition that mark between a source, field, attribute, or column into a destination one. As part of the mapping, first of all, you can rearrange the order of the columns, you can skip some of the columns, you also can change some of the types, slight differences of the type, data type, into one column. And one of the strengths about it, that even if you have different formats, JSON, Avro, CSV, and Parquet, that will be ingested into one table, mapping is it's a very simple but powerful tool that will enable that by just changing the mapping, the setting of the mapping name as part of the flow. And everything will ingest into the same table and will get per the mapping rules. Another phase as part of the ingestion, once the data is arrived, first of all, as we described, as I just described at the beginning, the data arrived into the service. First of all, the DM arranged it into one Azure queue that manage everything, rearrange it, whether it's a merge between queues or split between blobs, whatever it's needed to get into the most optimized size. And then we move to the mapping, that is set of rules that help the customer, that help the system to understand how to ingest the data. What are the set of rules from source to destination to ingest the data? And once the data is already ingested, there is an additional optional steps, which is the update policy. Update policy, it's actually trigger, which is slightly different than the triggers that you're familiar with. The update policy runs on the destination table, derived table. So whenever a new records ingested into the table A, the source table, automatically all the update policies in the derived tables that point into the source table A will raise up, run their query, run their logic, their functions, and ingest the results of their function into the destination table. So it is the trigger, it's part of the ingestion, and it's a help customer whenever they have multiple sources that arrive into one table and they want to divide it into different tables, or whenever they want to make transformation, or whatever they want to make some adjustment with the table structure. It's like a very simple ETL procedure that runs as part of the ingestion. Be aware, it impacts the latency and also the CPU consumption of the ingestion flow, but many of our customers use it with source table with retention 0 and destination table, derived table with longer retention period for that are subset of the original table. Next, so we have learned of the ingestion of the arranging of the data, that retries, the throttling, the mapping, and then the update policy. And the next thing that I would like to mention is about the flavor of the ingestion that we support. There are two main flavors, which is the batching and the streaming. And the very clear question is, whenever we describe, and I'm pretty sure that Oded in his session described that Azure Data Explorer is a new real-time analytics data platform. So you can reach your data from seconds, even couple of seconds, into minutes, even more, depends on your customer needs. So how can you select what is the right flavor for ingestion for your customer, for your needs, whether it's streaming or whether it's batching? In many cases, customers say, oh, I need to cut the data very soon. I need it as fast as possible. Let's go with the streaming. Let me give you some hints here. First of all, batching is the most optimized way to ingest data into Kusto. Whenever you have a lot of information, a lot of data that you want to ingest into one table, most likely batching will provide the best performance. Batching is utilized by 3 parameters. The first one is time, 5 minutes. The second one is size, whenever we get into 1 gigabyte of data. And the third one is the quantity, whenever we get into 500 units that were ingested. Once the system meets with one of the criteria, the data immediately will sealed and will be ingested and available for query. Those 3 parameters are adjustable. You can update it easily with the command or with the UX at the Kusto Web Explorer. And the recommendation, and there is a set documentation that we have released, how to ingest our data, how to perform our ingestion process that gives some hints how to adjust those parameters. For example, if you have very big files, it's better to change the unit numbers into smaller numbers. If you have smaller files, it's better to increase this number. And again, all those advices we published in the documentation, frequently asked questions, documentation of ingestion. And again, we are also available for question for performance utilization. So we talked about batching. We described that this is the default option, the most perform option for ingestion. But actually, streaming is also a good option whenever you have small amount of data that you would like to ingest per table, or lots of information or bunch of information that you would like to ingest into multiple tables, but in overall, each table would get small amount of data. And the requirements here is also to have to access the data in a couple of seconds. Streaming is the best way to perform that. Whenever you have that, just define the database and the table for streaming. You can do it as part of the database definition, and you can also do it as part of the table definition. You can have it in the and also whenever you define event tab in Kusto Web Explorer, which is also streaming enabled. You can change the table to be streaming enabled, and then automatically the service will ingest the data and will enable the query of those new records together with the history records in a couple of seconds. And don't worry, in case you thought that the best way for you is streaming, and with time the load of data was increased, and now the best performance is use batching. At the back end, there is a mechanism that utilizes the performance of the streaming, and whenever we reach a specific amount of data or specific amount of CPU usage, we just automatically change it into a batching mechanism to optimize the performance of the cluster. Okay, so you can see here that from the architecture aspect, we try to provide as many pipelines ways to ingest data into Kusto. The data arrives from different pipelines flow, whether it's as one of our SDKs, one of our managed pipelines. I will elaborate in a second. One of our connector or plugins, open source or Microsoft internal, and of course, one of our tools. We can ingest the data. If you want to try, if you already have a working project, wonderful. If you want to try it and you have some concerns about how to start, my best suggestion for you is just fork your data, your existing pipeline in your existing services, fork it in one of the pipelines that already supported, and send the data also to the existing services together with the new, with ADX, and test it, perform it yourself. Also to understand the capabilities, all the stuff that Oded, me, and later all of my great colleagues will share, and also for you as a learning experience. So the data will arrive into the connectors. Once they arrive into the connector, we arrange it into a batching to get the best performance and the best sizes for query capabilities. We ingest it into the engine, and of course manage from the metric to verify the best success rate of the overall ingestion flow. So as I mentioned, we are trying to enable as many options as possible. I have a belief that I already forgot some of the options that we have, but there are many. We support different protocols. There are APIs in almost every non-programming language. There is also the different flavor of ingestion, different connectors. Some of them managed by the open source community. Some of them managed by us. Definitely, you can reach to us if you have any questions, or if you need any support or guidelines how to start, or who is the one that managed those connectors. The managed pipelines, also to consume the data with one of our UX instrument or dashboard tools, and of course, there is also visualization. Okay, any questions? Henning, do we have questions here?
So yes, okay, so one of the questions you already answered on latencies between comparing streaming ingestion and then batching ingestion. That's one that you already covered. Do you want to elaborate a little bit more on that?
Sure. Let's go. Let's get back to this. Okay. So first of all, as I mentioned, whatever streaming, whatever you need, first of all, ask yourself, what is your need? If you need to access your data in immediate response time, this is a good way to start to explore the streaming option. But before you go directly to streaming, see what is the size, what are the parameters that you need to ingest. If you, for example, need to ingest a lot of information, couple of giga, even half a giga, or things like that in seconds, this is another option to go to batching. If it's only a couple of records, if it's per table, if you even want to ingest thousands of records, but into multiple tables, go to streaming. The guidance is most likely batching will provide you the best performance, but if you need a couple of seconds near real-time performance, streaming is your answer.
Thank you so much for that, Svea. Maybe one more clarification. Not specifically in this round, but I've heard this from previous customer conversation. Does it actually, so those kinds of batch ingestion and streaming ingestion, do I need to have an event hub ingestion for that, or does it also work without an event hub? So what is the relation from event hub, streaming, and batch ingestion?
Wonderful, good question. So first of all, to enable streaming, streaming is unrelated to the source of the data. But in order to have an access fast, end-to-end near real-time response time, the idea is that the pipeline, the end-to-end pipeline will support streaming. So streaming can be supported by one of our SDKs. It can be supported by Event Hub, Kafka, IoT Hub. There are many pipelines and our programming languages that support streaming. So no, it's not only with Event Hub, it's also with Event Hub.
Very cool. That's great to know. And then there's one more question on that one. So somebody wrote in the chat and is talking about KQL transformations. I guess the person is talking about update policies. So does it make a difference if you run update policies on a table that is ingested by streaming ingestion versus batch ingestion? Does that make a difference?
Till a couple of months ago, update policy was support. At the beginning, we didn't support update policy for streaming. It's something that we work on it, and it's something that today we have support for both of them. There is slight difference on the performance on that and on those area, but not something that required any specific highlights at this point. Okay,
very good. Do you want to take one more question?
Yeah, sure. We have time.
Okay, cool. So now it's about volume of data that should be ingested. And somebody in the chat is asking about Azure Data Factory. And if the person is asking, yes, okay, cool. The second part of that question is about deduplication. Svea, you don't need to answer that. I'm going to answer that question probably tomorrow. I'm definitely going to answer that question tomorrow in our hands-on lab. How to deduplicate vast amounts of streaming data ingested into Kusto, and we're going to use materialized views in order to deduplicate data. But ADF was one point. Okay. Please go ahead.
So first of all, listen to Henning. His sessions are very, very interesting. There is also the Kusto Azure Data Explorer blog There is an article about how to manage duplicate records in tables. So you can also go there as a reference after you listen to Henning. Okay, let's continue. So we were here. Wonderful. So as I mentioned, we are trying to provide a very rich and the various ways to ingest and actually query and manage Azure Data Explorer clusters, databases, and tables. We will share the deck later with you. So all the ways are linkable to the code, to the documentation. Just click on it, and you will get all the information about that. Now let's talk about Azure Data, about tools. There is also different tools to manage and to ingest data. The first one is Azure Data Factory with a data flow and copy. We have a couple of ways to manage with Azure Data Factory. The first one is the copy activity. Kusto can be, Azure Data Explorer can be the source and the sink for copy activity. And you can use it also to copy data from different sources into Azure Data Explorer and from Azure Data Explorer into different destinations. When people ask me, what are the key scenarios to use ADF? My principles are, first of all, whenever you would like to support format that is not one of the listed formats of Kusto, something that we don't support today and we would like to add it, use ADF. If it's a source that is not supported by Kusto, by Azure ADX, for example, on-prem, different databases, different cloud services, ADF is a wonderful orchestrator to bring data from source into Azure Data Explorer. Another scenario is whenever we would like to bring backlog, history data, backfilled, and just ingest terabytes and even petabytes of data in one bulk historical data, ADF is a good tool for that. The reason is, first of all, you can manage it, you can divide it into different pipelines. You can also have the parallelism to increase performance. You can also have the ability of historical data. What does it mean? It means that once you put the historical data, the data will be ingested with the actual creation date of the ingested time instead of instead of the today day. Why it's important? All the optimization of query, the creation of shard, partitions, indexes, parallelism, and also divided into different cores in Azure Data Explorer is managed by default by the ingestion time. So if we bring historical data into Kusto, and we just ingest it in one bulk, one of the challenges that all of them get the same ingestion date, and all the historical data get today or the date of the ingestion are their ingestion date. So the shards, the partitions, all the indexes are built wrongly, which provide a poor performance later on the query. What we suggest is that whenever you have historical data that you would like to ingest, use the historical settings in ADF, also in light ingest, which I will elaborate in a second, to mark the correct ingestion date of the records instead of the later date of the second ingestion. So ADF is very good. We have it in copy activity. We have also command, ADX command. With ADX command, you can also have the ingest command, which is very good to ingest from storage and manage it by ADF. We have data flow that can also help with transformation, more complicated ETL of the data, merge between tables, separate tables, and whatever is needed is managed also by the ADF. And lookup. If you want to have something, in loop, you're just gonna run query, get the results, and loop the pipelines by this lookup. So this is the ADF. We also have light ingest. Light ingest is actually a command tool, very simple one, that it's helped with a very basic capability of bulk ingestion of historical or non-historical data into Kusto from Azure storage. I will demonstrate a little bit more later. And it's very good, it's very easy, very good, usually run on Windows, so be aware on that. And again, whenever the source is files, local file, blobs, or ADLS Gen 2. The third point is one click. One click, actually, it's not one click, it's 4 clicks, to be honest, but it's a code name of smooth ingestion. Many customers that they're working with their experience, with their data, not usually are very familiar with the data structure. All of us familiar with the structure, all of us familiar with the data. But sometimes it takes us time, and sometimes we are doing some simple mistakes that take some time to fix later. With one click, the idea behind that is to help as much as possible to our customer to bring their data into Kusto in the most precise way and the easiest way. The idea behind one click is to have less than 5 minutes from source into destination, and with minimum clicks. The inference is the best way is just to present it. Welcome to Kusto Web Explorer. Kusto Web Explorer is the web version of the consumption experience of Azure Data Explorer. Whenever you get in, you will get this page, which most likely you're already familiar with. You have also here the free cluster, again, for a separate session. And here there is this logo with the database, linked database that's called database management. At the database management, you have here a couple of tabs that provide several capabilities. The first of all is manage. What does it mean, manage? To create table, create external table, also to see and to update the table retention policy and the table batching policy. Batching policy, I would like to remind you, the 3 parameters of time, size, and quantity, amount. I can select at any point, any table at the system, and I will see what are the settings of this table. At this point, I can decide whether I would like to increase or decrease the number, the seconds, or the size, and just update. And that's it. The settings of this table was updated to 100 items instead of 2000. It's very good for bigger size file, for medium size file. 2000 is better for very, very tiny files. So this is one of the options of manage. Create table. I can select at any point to create a table. I am the worst person with names. So whenever I do demos, I just use my name. Sorry. It's pretty boring, but it's useful for me at least. I can create tables from different sources. It's very easy and smooth. I just need to select my source. For example, if I don't have a source, no problem. I just move to the schema page and I can create my own table structure. I can call it TZ1 from type string and TZ2 from type dynamics. And guess what will be the third column name? Correct, TZ3. And I can decide that it's real. Save it. And then I have a new table. I can just create it. And that's it. I have a new table called Svia1. At any point, I can get back to here and I can change my rhythm. I can do it as create table from a source. A source can be blob, file, container. I can select any of my containers. I can select a file from there and an inference. Okay, but you know what? I will keep it for a second. You know, I will do a simple one. And for ingestion, I will do something else. I can select any file as the source of the structure. At this point, at this moment, an inference run at the backend and take a sample of the file and infer what is the most appropriate structure for this source, for this file, and suggested it to me. At this point, I can go and make any adjustment of the data type, of the columns, add new column, change names, remove columns. I can change the nested level to have it less dynamic, more dynamic, depends on my needs. I have full control of the data structure. To be honest, most of our customers just keep it as it is and move forward. For me, I will keep it like that and I will just create a table. At this point, I will have a new table and, okay. There was a okay. One more thing that I would like to present is now after this is the managed part. I also have the one-time ingestion and continuous ingestion and the backfill. The one-time ingestion, I can select any source, whether it's local files, blob, list of blobs, container, or ADLS Gen 2 folder, and to ingest it as it is into a table, existing table or new table. I can have a similar experience, but also with continuous ingestion from container or from event hub. At this point, as part of the ingestion pipeline, I will also select the source. For a continuous ingestion from container, which will be ADLS Gen 2 or blob container, I will select the source. The inference will infer the schema, ingest it into the table, and then automatically will create all the requirements resources that will needed to create continuous ingestion from this blob. Whenever a new blob will be created in this folder, in those folders, or whenever a new blob will be renamed, automatically the data will be ingested into the table. All of this, as you can see, we will present in a second, in 4 clicks. Also from Event Hub, same. I can select any Event Hub that I have in my folders, in any of the subscription that I have permission to. I can select one of my Event Hub. The data connection name will be auto-generated. I can make adjustment if I want. I don't have to. I can select one of the consumer group or just create a new one. The data can be compressed or not. I can also add to each record what system properties that are coming with the events. And at this point, what is happening, we are waiting to events to be generated, to be streamed in the pipeline. Once data is ingested in the Event Hub, this inference takes a sample of those events, infer the schema, same as we did earlier. And here, this is the table that are suggested to support this Event Hub. At this point, I can make adjustment, of course, as I did before. I can change the structure into, for example, JSON and make a better table structure. I can do many things. I can bring more data. I can just decrease this data or bring more and move to ingestion. Once this will be completed, the continuous ingestion is working in production. Means that all the data that will pipe in this event tab will be automatically ingested into the destination table. And I did it with a couple of clicks. Is it doable? Okay, nobody comments. I will comment myself. I believe it.
Yes, it's doable.
Okay.
Yeah, people can't come off mute. It's a Teams like.
Yeah, I know.
Otherwise, everybody would have screamed and shouted, yes.
Yeah, I know. This is why I love in-person sessions much more. Okay, I would like, for backfill, if we have historical data, I want to bring more, now terabytes of data. For that, we also have the ability to use light ingest. And one more thing, which is actually very cool stuff, if you would like to start to program with Kusto, with Azure Data Explorer, first of all, our documentation, here you can see for each and every connector SDKs that we have, you can see that we have a very good documentation. We hope that are good. If it's not good, please feedback us. And another thing is the generate. Today we have support for Java and Python, and now we are going to release also .NET and Go. This is the next one. So we are going to release 2 new versions. What is this generate to? Very simple, very similar to the ones that we presented, but the results of this flow will be a working package of the language that connect to your cluster database, do all the authentication, ingest data, query, create table, ingest data, query it, everything with a lot of documentation that help you to enrich it with your own experiences. So it's a kind of tailor-made code generator to your own resources, which we believe can help to simplify the work with our programming languages in Kusto. Okay, I don't have a lot of time, so you will kind of.
Yeah, this was amazing. Maybe there's a question. There's a question in the chat. What happens if the schema is evolving over time? Let's say you create a managed ingestion. You define a mapping for a JSON, and then the JSON changes over time.
Okay, so today, here as part of the flow, we have the alter command. If we are selecting one of the existing tables, we will auto-generate an adjustment of the tables. It's not necessary. You don't necessarily need to start with a new table. You can select one of the existing table, and the command will alter the table automatically per the schema. We're also working and exploring options to make adjustment with the schema as part of the ingestion pipeline, but we don't have a due date to support it automatically. Today, it's part of the flow, the manual flow.
Right, and probably also as an alternative is if the input is really changing dramatically. Then there's like a couple of options that you have. Either go for an ETL process, which is harmonizing the data model, and then you make sure before the data is actually hitting the database that you do this. Or if you can separate the streams between like the new data with the new model, you can just ingest the data into a new table. And then you write a function which is querying both tables and unioning the data. So there are plenty of options.
One of my favorite options actually is to work with the data as a dynamic. If I know that this table is changed often, as instead of trying to manage those updates, just create this table more flexible with dynamics columns and ingest the data as it is. More questions?
No. Actually, I don't see more questions here.
Okay, one more last thing before, almost last thing. People ask me many questions. Ask us, actually, as part of the ingestion time and just of the ingestion phase. Where is my data? What is my latency? What was wrong? What is missing? You know, many questions. First of all, there is the frequently asked question documentation that answers those questions. One thing. On the other side, there is the insight page. At the portal, Azure portal, at the cluster, there is insight page that gives a very detailed explanation and actually status of your cluster. Overview, CPU, materialized, everything. But I would like to focus on the ingestion part. At any point, you can see how many successful flows you did or how many failures you had. What is the total latency, the utilization. You can see here by table, by database, those details. And if you go down, you can see here that we have 4 phases of ingestion: the data connection, the batching, the ingestion, and the storage. At each point, you can see and actually explore into the information and to understand what is the status of your ingestion, whether there is something to optimize. This is a very good point to start to explore and to understand how to optimize and get insight about it. So please be aware of this page to take control of your data. Okay, so I just give you a hint. The demo was pretty short. There is much more capabilities to ingest data with one click as one-time, bulk, continuous, manage your cluster, manage your retention, everything with friendly UX, user experience, and explanation. And as I mentioned, the one click is responsible to get data from different formats, different sources, different structure, infer the schema automatically, give you the freedom and the ability to manage it in the best way, and then to ingest it as a one-time, as a continuous ingestion, as a bulk with historical data, to manage your data in one place. So this is the insight. Whenever you have problem, there are very good documentation. There is the insight page, and you have us as well to support. Documentation, Q&A. So this is data management in 30 minutes. I hope that, I know it was short, but I tried to give hints on the most important stuff that you will be able to mark to yourself and also take it afterward to Richard more.
Oh, Svea, this was amazing. Thank you so much. I mean, we already covered parts of the questions during your talk, which I found really refreshing. And by the way, guys, I just want to remind you, every attendee is also getting the recording. And if you have other questions, you know how to find us somewhere on the internet. We are present.
And my LinkedIn.
Yes.
All the updates, all the documentation, follow us. Azure Data Explorer, Svea, Henning, one of us. We are trying to be very communicative there.
Correct. Svea, by that, I would like to say thank you. Thank you very much for your session. And by that, I would like to hand over to you, Slavik. Please feel free to introduce yourself, share your content. Thank you so much for being with us. Take it away.
Hi, guys. Hi, everyone. I'm excited to be here. My name is Slavik Neymer, and I'm a principal software engineer at Microsoft in Kusto, or Azure Data Explorer. And today I'm going to introduce you to KQL, which is the Kusto Query Language. Now, this language I'm actually going to show you some demo. It's best, right? I was just about to give a few sentences of how great KQL is, but you'd better see it. Okay. Henning, can you please confirm that everyone can see the screen?
Yes, we can see your screen. Confirmed.
Perfect. So hello, everyone. I'm going to go over some table, which is called Storm Events. It's accessible to everyone with a Microsoft account for free, of course. So whatever you see here, you can try yourself. You can do it during this demo, or you can do it after. You'd better do it after. So let's look at this data. I'm going to have 3 parts in this presentation. The first one is just exploring the data. It's going to be very, very basic, just to show you what KQL looks like and how you write basic queries. We'll then go to some more interesting stuff, which is getting insights from the data and not just looking at the records. And then I'm going to have the third part, which is some more advanced KQL queries. Okay, so let's start by looking at some arbitrary 10 records from the storm events table. Now, the storm events table contains data from all the storms that happened in the United States in the year of 2007. If we look at 10 arbitrary records, I can run the query by hitting Shift-Enter or just clicking here. I prefer to use the keyboard because I'm a keyboard guy. And you can see here that for every event, there is a start time and an end time. And for every, there's an episode ID, because there can be a storm with multiple things. For example, it can start with heavy rain and then cause some floods, as we'll see after. And we can also see in which state the storm happened, the event type, and we can also see how many people were injured directly from the storm, indirectly, deaths direct and indirect. And we can see the damage. Now the damage is split into damage to property and damage to crops. And there are many, many more columns here. We're not going to go over all of them. Let's look at how many records there are in the table. But just before I do that, let me pause just for 30 seconds on this one. In KQL, when you write queries, you normally start with your source, with your table, and then you use the pipe. The pipe sign is actually telling, it's actually saying that you should take everything from here and pass it to this one, to the next line. As you can see here, we start with the storm events table. We then take it and pass it into this filter, and the output is passed into this one. So taking 10 records was easy. Now let's count how many records we have in the table. That's very easy as well. We just look at the storm events table and use the count operator. Okay, so we have about 59K events in 2007 in the United States. Now let's see at some storms which caused damage to crops. How do you do that? I use the where operator, and I can write any condition I want here. The simplest one would be a damage crops greater than 0. And then I take 50 arbitrary records. And if I scroll to the damage crops column, you can see that the numbers are indeed greater than 0. That was easy. Now, suppose I want to find the events that cause damage to property or to crops, specifically in Florida. So I can, as I said, I can do any condition here. So I do damage property plus damage crops greater than 0. Then I have another filter, which is state equals Florida. Then I use a new operator called order by. Well, it's not new, it's new in this presentation. And I want to order all the results by the damage property column in descending order. Let's see how it works. As you can see here, the state is Florida indeed in all the records, and the damage to property plus damage to crops is indeed greater than 0. Let's look at the sorting. Damage property. Order by damage property, descending. That didn't seem to work. Maybe because they sorted the data by clicking accidentally something. I have no clue. I don't know what happened here. Okay, let's look at events that caused most damage to property. So I use a new operator called top, which returns the n amount of records sorted by the damage property. Okay, this one didn't work. I think it's some. I know what. I applied some filtering on in the Explorer here. And I need. It's a UI. I think that I did because. Okay, now that I removed the sorting, then I can see that this one will work properly. Damage property is indeed sorted, and this one is sorted as well. I'm sorry for that. Okay, good. Okay, now let's look at another filter that we can do. For example, I want to see which event types, which records have in the event type the word wind. And then I want the top 5 records by damage property. As you can see, we got a couple of different event types. Both of them contain the word wind. So that's very useful. Now let's find the last query in the exploration section is one that helps us find events that cause damage to property in Florida, specifically in the first quarter of 2007. The way I do it is I filter by start time, that is between 2 date time literals, between January 1st and March 31st. Then I filter by damage property greater than 0 and state equals Florida. Notice that I use and here. I could actually put all the conditions in the same where operator. I just find it more readable when I write it this way. And I also use a new operator named project. Project lets me choose which columns I want to see in the output. Because currently, as you can see, I have too many columns. I'm not really interested in all of them. So if I run this query, I can see just start time, event type, and damage property. Okay. Let's move on to the next section. Up until now, we just looked at records that exist in the original table. But we want to do some more stuff, more advanced stuff like aggregations. For example, I want to see the total damage per state. How do I do that? First of all, I need a new column named damage, which will contain a calculation of damage property plus damage props. Then I want to summarize this damage column by the state. And then I want to take the top records sorted by the sum of damage. Now, note that when I do summarize of sum damage, the new column automatically gets the name sum_damage. If I wanted, I could say here new column name, and then, as you can see, the IntelliSense, about which I want to talk to you in a second as well, says, I don't know what sum damage is. So all I need to do is replace it here, and then it will work. So let me run this. And as you can see, I indeed got 10 results. You can see it here, 10 records. And they're sorted by the new column name. If I go back, then it will have the default of some damage. And you can see that in California, the damage was by far the most significant. Now, about IntelliSense, we have auto-completion in KQL. So I can just press Control space and I see all the tables that I have here. For example, I want to go to storm events. Enter. Now I want to do extend damage. I'm just rewriting the query from before. So as you can see, very easy. It just helps me with pretty much everything. I can see all the functions here and all the relevant columns and by what column I want to do the aggregation. And if I do top 10 by, it gives me all the various options, including this one, which is deduced automatically from this line. So it's very convenient to write KQL queries. Okay, let's get some statistics of storms per state. What I do here is I use the same summarize operator that you saw in the previous query, but instead of just using the sum, I use some more aggregation functions. For example, count, which counts the records, COUNTIF, which counts the records for which this predicate returns true, the distinct count of event type, meaning how many different event type values in the event type column we have, the minimum start time, maximum end time, and the aggregation is done by state. The way it works is Summarize looks at all the records from each and every state separately, and for each state, it calculates all these. Now you will be able to see it in the result here. For every state, I have the amount of records, the amount of storms in 2007 in the United States, and how many events caused damage to crops, how many different event types we had. You can see here that we have a pretty high amount of different event types. We'll go over them in a minute. And you can see when the first storm started and when the last storm ended. Now let's look at all the different event types. As you can see, there are quite many here. And the way I do it is I use the distinct operator. The distinct operator just takes this as an input and returns all the distinct values for this column. By the way, if I wanted to get the distinct combinations of two columns, I could have just written a comma here and another column. But for now, I want to just see the event types, and I want to order them by the event type in ascending order. You can see here that we have 46 records, meaning we have 46 different event types. That's quite a lot. Let's look at which ones are the most frequent ones. How to do that? You already know. I just summarize count by event type, and then I take the top 5 records. Okay, thunderstorm wind is our winner. Number 2 is hail. Let's look at a chart of how many thunderstorm winds events we had every week. How do I do that? First of all, I filter event type equals thunderstorm wind. Then I count by, this is something new. I want to look at the start time, but I don't really want to know exactly when it started. I want to round it to the lowest 7 days point. And then we have something new here called render. The render operator allows us to return not just a table with data, but a graph or something visual. In this case, I want a column chart. If I run this query, I can see for every week the amount of thunderstorm winds. You can see here that it's June 4th, June 11th, June 18th. Indeed, the difference between every two columns is 7 days. Or I could write it in short as 7D. That's what you do. That's what we usually do. Okay. Now we can do the same by a month. The way I do it is I replace the bin start time 7 days with start of month by start time. Here you can very easily see, just like on the previous graph, you can see that most thunderstorm winds occur in the summer. I really have no idea why. But this is the data, and data doesn't lie. Okay, so let's do some investigation in a single query. We'll do exactly the same thing. Instead of typing here thunderstorm wind, I want to find it inside the query. How do I do that? Let's learn about let. A let statement, something that ends with a semicolon, is something that you put just before the query, and you can do. It allows you to do 3 different things. Number 1, you can define constants, as we'll see in one of the next queries. In this query, you can see that we can run a query inside this let statement and store its result. Number 3, we'll see it in the future, in one of the next queries as well, is you can define a function that you can run as part of this query. It's let statements are very useful mostly to write readable queries that are very easy to read, and they are sometimes required for more optimized queries. For example, if you want to do some calculation that is pretty heavy, and you want to use the result multiple times, then you can write a let statement here and use the materialize function that will just run everything and remember the result. I'm not supposed to run materialize on to scalar, and that's why the IntelliSense isn't happy with me. Okay, so what I want to do here is run this query that you already saw, right? If I run just this part, and yes, I can select just part of the query and click run or shift enter, you can see the event type and the count. All I want is the event type. So I use the event type, the project event type here. If I run it, you see that I got only thunderstorm wind. What I actually got is a table with a single column and a single record. This single cell contains the string thunderstorm wind. But I don't want to have it as a table. I want to have it as a string. So what I do is I call the toScaler function, which receives an input, and it takes the record, the first column, and stores it as a variable, just as a scalar. And now I can use it here instead of this constant. So if I run this query, I will get exactly the same result, not surprisingly. Okay, let's get events with the most damage to property and crops. How do I do that? I use the extend operator that we saw before, which can add new columns to the table or override existing ones. In this case, I create a new column called damage, which is the sum of these two guys here. And I take the top 5. Then I only want to project 4 columns. As you can see here, we have the start time and state and event type, and the damage of the five storms that cause the most damage to property and crops combined. Let's do something a little bit more advanced. Here you can see that I use a let statement where I just store a single value, which I don't calculate. It's useful because it makes the query more readable, I think. And also I can, if you put all the constants at the top, that's the best practice, then it's easy for you to just change the constants here, and you know that you should never worry about going over the query and change anything, but it's just a matter of style. Here I want to define another let statement with named small states, which looks at the population data table, which looks like this. For every state, it has its population from some point in time. And I want to look at only states in which the population is smaller than 3 million. Okay? Now I want to look at storm events where the state is one of these ones, one of the small states. By the way, if you want to see what small states looks like, I can just run it this way. And here are all the small states. And now I want to look at all the records in storm events, but only those for which the state is one of these guys here. I then do the usual stuff that you're already familiar with. And as you can see, the storms that caused most damage in these small states is this one. It was in Mississippi. Okay, but this one actually looks quite useful. Maybe I will want to use it in other places. So I can go on and create a function that returns all the states with population lower than some amount, which is an argument to this function. Here inside, I just write the query. Create an alter function, function name, arguments, and the body. I run this one. I get the result saying that everything is okay. By the way, note the dot here. When you start something with dot, then it's a command. The previous things, everything else that I ran up until now, did not start with a dot. Now, if I run this function that we've just created with, for say, 1 million, I will get all the states where the population is less than 1 million. If I run the same query as before, but instead of defining the function within the query, I can now run it by just using the function that we've defined before, and we'll get the same result as before. Now, if I want, I can use the join operator, which receives this as an input and joins with this on a column that is state. We can join by multiple columns. Of course, we'll just need to separate them with commas. In this case, I want to look at population data, filter those states where the population is less than 3 million, and then I want to join them with the storm events table that you're already familiar with on state. So what the result will be is all the storm events with the state and the population in that state. And now we do the usual stuff that you're familiar with, plus I project the population column. Here I got exactly the same result as before, plus I see the population. Indeed, the population for all the records here, for all the states, is less than 3 million. just like what we wanted. Now we have many different kinds of joins. Usually what you want to use is the inner kind, which is just a Cartesian multiplication. You just take every record from the left side and look for a match in the right-hand side. But there are other types of join, which we won't go into currently. Just like we have join, we have unions, of course. I can look at population data where the population is less than 1 million, and union the result with population data where the population is greater than 25 million, and order by population. You can see that it worked. And this is obviously not a great way to write it. I could just write population less than 1 million or greater than 25 million. It will produce the same result. Just wanted to demonstrate the use of union. Before we go to some advanced queries, Henning, do we have any questions?
A ton of them. Unbelievable. Really? Yes. So,
oh, wow.
So Slavik, you're doing an amazing job. So first of all, like questions that come up, like let's start with simple questions that are probably not so simple. Why the heck do you want to like have more than one where statement? Why do you want to do two where statement with two pipes? And what is the potential reasoning for that?
Okay, excellent question. It sounds simple. It's not so simple.
Yeah.
The answer is, the simple answer is it's a matter of style. If I have multiple where statements, I can write them this way, or I could write them this way. It doesn't matter. Performance-wise, it doesn't matter. I didn't talk about it, but Kusto actually performs a lot of optimizations on the query. It doesn't really run like you would expect it to run based on what you read. It's not that we take the storm events table, we fetch all the records, and then we're doing this filter, and then we're doing this filter. We do it in a much more sophisticated way so that queries over huge tables perform super fast. That's the whole point of the product, right? So one thing that is important, and I do recommend doing, is that the filters should be in the order that filter out most records. For example, if you have some filter that filters out 90% of the data, and then you have a filter that filters only a little bit of some edge cases, then you should first write the filter that filters out most data, and only then have the second filter. But it doesn't really matter if you put them in one where statement operator or in multiple. It doesn't really matter.
Great, thank you for that. And you already led to the next question, which you already partially answered. So is there some query optimization in KQL behind the scene? And I guess you already answered that, right?
Yes. We have a huge amount of optimizations that allow you to run very complicated queries over huge amounts of data, and the results will return just super fast. This specific table is really tiny. It's just 59K of records, but we normally, on our day-to-day job, we perform many queries during the day on the table that contains, that gets about 100 billion records per hour. We store data for 1 month back, and we run queries on it, and results return within seconds, usually sub-second. So yes, we optimize queries, and you normally shouldn't worry about it. When you write super complex stuff, you should consult the Kusto Query Best Practices doc. Just look for Kusto Query Best Practices, and you have multiple suggestions here on optimizations that you can do that Kusto cannot do for you because you have more knowledge about your data. One example that I will provide here is, here I use the has operator. When I run this query, it returns all the records in which the event time has the word wind. Now we also have a string operator named contains. Contains, what it does is looks for wind as a substring, and it can find not whole words. What it will, the performance of this one is less optimal because we have significant optimizations for has. So we can't replace contains with has for you, but in mode, so this is something that you should do as somebody who knows the data.
Perfect. Cool. There was a comparison between, there was a question comparison between has and like, but I think you answered that.
Yeah, we have many different operators here. We have has prefix and ends with and whatever you want. You just look for Kusto string operators, and you can see a pretty impressive list here.
Yeah, and maybe one thing that before you continue, I think we didn't talk about this so far. You ingest all of this data. We've seen the storm events, and then you create a schema for that. But this has query that you just wrote, does it actually hit the data, or will it hit first some sort of an index?
Of course, we use an index for that. Otherwise, queries would be too slow.
Yes. And is it fair to say that you don't need to specify that you want to have an index? It's created for you out of the box, right?
Yeah, so that's actually a great comment, Henning. Thanks. Kusto indexes automatically all the columns. So you don't need to worry about thinking which columns I'm going to use in the next, I don't know how much time. And the more indexes I specify, the longer ingestion would take. So you don't have to worry about anything of that. You want to ingest as much data as you want. You want to ingest just everything. Kusto will take care of indexing all the columns and doing the optimizations for you. For example, if I want to see how many records here have a number in injuries direct greater than, I don't know, a certain value, then we look at bulks of data. And for each one, we know the minimum and the maximum value of this bunch. A bunch normally consists of multiple millions of records. And if the value that I'm looking for isn't within the min-max range, then we just don't read the data for this chunk of data, which we call an extent or a shard. We use them interchangeably. That's actually an interesting concept, and we won't talk about it in this session. But we're storing data in shards in a very compressed way, and we have indexes on everything, and yeah, everything is optimized basically.
Cool. There's still a couple of other questions, so probably we'll summarize them up in the end. So please feel free to continue, and we'll answer the questions in the meantime.
Okay. Okay, let's do a few more advanced queries. So here we want to find what were the top 3 most common events for each of the states. Now let's run this query just to see the result. You can see now for every state, the 3 most frequent event types and how many times this event happened. This is pretty powerful. Right? You can see for every state the 3 different event types and the count for each one. How do I do that? First of all, I have to summarize the amount to count the number of events per state and event type. So I get a pretty big result here. Well, not big by Kusto standards, but about 1,000 records. Now what I want to do is use the top nested operator to look at each state, take the 3 top records by event time, by the sum of events. And here you can see the result. So that's pretty powerful. Now let's do another query. Let's find all the events that happened at an episode with most tornadoes. Now, an episode can start with one thing and evolve to another thing and cause another thing. So we first of all have to find the episode with the most tornadoes. How do we do that? We look at storm events. We look at event type equals tornado. By the way, note that here I used the single quotes to wrap a string. I could just use double quotes. It doesn't really matter. Both work the same way. You can choose either. I usually choose double quotes when I need single quotes within the string, and I use single quotes when I need double quotes within the string, so that I won't have to escape. Now I summarize by episode ID, the count of events, and I take the most frequent one. And I only want to look at the episode ID. Let's look what it looks like. If I just run this, then for every episode ID, we'll know how many tornadoes there were. If I sort by events, I will see that this guy here, there were 27 tornado episodes during this storm. What I want to do next is look at the storm events where the episode ID is here, one of these. Here I return just one, but I could return multiple. I use the in operator just to show you how it works. It takes a set of elements. So you need to project a single column here. And after this filter, I just want to sort by the start time. And you can see that the data is sorted by the start time. We have 91 records. And if I look at how it evolved, it started with hail, and then we had some floods, and then we had more floods and tornadoes. And if I sort by the event type, I will see that I have quite many tornadoes here. Not fun. So the pictures must be pretty. Okay, and the last query for today is I want to find when heavy rains caused flood events. How do I do that? First of all, I want to find all the records, all the storms in which there was a heavy rain. And I create a new column named rain time, which just gets the value from start time. Then I do the same for floods. I just do the same thing with the word string flood here. Now what I want to do is look at heavy rain that we had above, and I want to join it with floods. How do I want to do the join? By the episode ID. Because you remember the episode ID is uniquely identifies an episode of a storm. Now I want to have a filter to look at only those storms in which the flood time is greater than the rain time, meaning that the floods occurred after the heavy rain. And then I summarize by taking for every episode ID, I take the minimum rain time, and I take the maximum flood time. Now take any is interesting because the episode ID describes a storm which can move between, which can occur in usually a single state, but theoretically in multiple states. In this specific query, I don't really mind in which state it started. I just want to take look at all the states within this episode ID and take just one of them. If I run this query, I will get 41 records specifying for every episode ID when the first heavy rain started and when the last flood started. Okay. Now, just out of curiosity, we can look if any of these events occurred in multiple states. How do we do that? I'll do it on the fly because I didn't prepare the query in advance. I just copied this one. Okay, the way I do it is I'll run the make set. I'll use the make set aggregation function, and this will give me the states column, a new column, which will contain an array of states. This indeed looks like an array of strings, and I don't know if any of them contain more than one state. But I don't really have to check it manually. I can just run where the array length of states is greater than 1. If I run the query, I get 0 results, meaning that all the episodes that started with the heavy rain and caused a flood, they all happened within the same state. That's the end of my demo. Are there any other questions, Henning?
Okay, so there were some more questions on the indexing side. So yes. When does indexing happen? That would be the first question.
Okay. When you ingest data into Kusto, the data is, you have multiple ingestion methods, just like Tzvi explained before. One of the methods is you just provide a blob in Azure Storage, for example, and you tell Kusto to ingest it. Once it's ingested, the ingestion process creates what we call extents or shards that contain the data. And Tzvi showed you in the insights page how to see the latency. Normally, the latency is very, very small, and the data gets into shards. And the way it works is that we go over the data that you wanted to ingest, and we create the indexes on the fly as we scan the data and compress it. And we write everything into our own proprietary format, which is super efficient. And once this operation completes, this data becomes queryable, meaning you can query it. So the indexing happens during the ingestion. It doesn't happen in the background. So as soon as the data is ingested, it's completely optimized.
Thank you very much, Slavik, for this one. We have another question, which is very, very interesting. And there's somebody who's asking, hey, Slavik, what is the kind of data that you should not store in Kusto? And I mean, he's asking it the other way around. He's asking, like, can I ingest voice data, dense data, data types, binary data? Does it make sense to store it in Kusto?
Okay, perfect. Excellent question. Kusto works really, really well with strict types like numbers. We have ints and longs and decimals and real, or double, same thing. We work really well with those, and with date times and time spans. All these work great. Kusto also supports free text, just string columns. These work great as well. You can look for substrings using the hash operator. You can look for regexes, regular expressions, and these work really well. Kusto also supports semi-structured data, which we call dynamic. It can contain an array or actually a JSON, right? A JSON can be an object or an array of objects or an object containing arrays of, you got the idea. And Kusto performs really well with those as well. What you don't want to store in Kusto is a binary data. For example, if you have I don't know, you want to store, you're creating your own social network, and people upload profile pictures. What you want to do is you want your service or application, whatever, you want to upload those photographs to Azure storage and get the URL, the URI for the profile picture. And this URI you should store along with the user ID in Kusto, because then you can get the URI very quickly, and then you query Azure Storage to get the actual picture. Another thing that I want to mention is that the data in a single Kusto cell, in a Kusto table, is limited to 1 megabyte by default. It can be increased to 2 megabytes by running some command.
Thank you very much for that, Slavik. One more question, maybe a more like a general one. Odette was talking a lot about log and telemetry data. Svea mentioned also, I guess, at some point, data coming from an event hub or IoT hub being ingested into ADX. In general, how would you classify? Is it fair to say that data ingested into Kusto could be classified as append-only data sets? And what is the engine actually doing in order to get that amount of speed out of the system by supporting append-only data sets?
Okay, wow, we have tons of good questions today. Okay, Kusto is an append-only system. Now, that's not entirely true, but pretty much. The idea is that you want Kusto to have, just like Odette said and the question repeated, you want it to store telemetry data, you want to store logs, you want to store huge amounts of data coming from everywhere. And it's not, you don't really want to store small things here and update a record every now and then. And so yes, Kusto is mostly an append-only system, which allows us to be very, very efficient. Now, there is a way to delete data. There are multiple ways to delete records. It is useful in some cases. For example, if you have IoT devices streaming data into a Kusto table, for example, you're a big company that makes smart buildings. They put tons of sensors in the rooms. They check the temperature and the moisture and the presence, whether there is anybody in the room or not, etc. And all this data gets into Kusto. Now, one day they may discover that one of the sensors was broken and reported corrupt data. And the user can decide that he wants to delete this corrupt data because it affects him, I don't know, it creates some noise in the dashboards. So yes, there is a way to delete records from a table. You can do delete table records. Delete table and the name of the table, records, and you provide a predicate here. For example, I want to delete all the storm events. Here I just provide a query. Storm events, where, I don't know, the episode ID is greater than 1000. I really don't want to run this command now because it will delete the data, so no. That's one way, we call it soft delete. Another way is a purge. You can run the purge command. The syntax is slightly different, but pretty similar. What it does, it deletes the data from the storage artifacts as well. This is the method that you should use when you want to delete data for compliance reasons. A customer asks you, delete all my data, everything you know about me. So you should use purge. It requires more system resources because, as I explained before, Kusto stores data in extents or shards with millions of records normally. If you want to delete some of the records in this shard, then if it's a soft delete, then we just add a Boolean column, an invisible column, marking records as deleted. But if you run a purge, then we have to re-ingest data from the relevant shards into new shards and delete the previous ones from the storage. So, and there are multiple other ways to delete the data, but mostly you should use Kusto for append only.